Question number 68. We have a parallel plate capacitor with a given plate area and plate separation, and the dielectric constant is given. So basically they have given everything to calculate the capacitance of the plate, and this capacitor with those given geometries or given capacitance is joined to a battery of EMF 6 volt through a resistor. Find the energy of the capacitor 8.9 microsecond after the capacitor connections are made. So when you join the capacitor through a resistor, the energy on it increases gradually, slowly, and as the energy on this capacitor starts storing, the charge on it starts storing, the voltage across it starts increasing, and as the voltage starts increasing, the energy on this capacitor starts increasing, and this energy E is given by half CV square, where V square is varying with time. Initially there is no voltage across this capacitor. As the time increases, we see a voltage growing, and this voltage has an exponentially growing graph, something like this. We need to find out at some point of time t, what is that charge value. Now CV square, we can also write it as Q square by C. Q square by C square, C cancels, so we get half Q square by C, where Q is the charge on this capacitor at a particular time of t. That means Q is a function of t, and Q has an equation. Q is equal to Q0 1 minus e to the power of minus t by RC. If you do not memorize this formula, you can either quickly derive it on the spot, or at least verify if you have a confusion if the formula is correct or not. You can verify it by putting t is equal to 0 and t is equal to infinity. When you put t equal to 0, this is e to the power of minus 0, which is e to the power 1 upon e to the power 0. E to the power 0 is 1, so 1 upon 1 is 1, 1 minus 1 is 0. So this whole thing Q becomes equal to 0 at t is equal to 0. When t is equal to infinite, this term is 1 upon e to the power of infinite, or 1 upon infinite, or 0. At that time Q is equal to 0. So Q tends to 0, Q0 at time t is equal to infinite. So our formula looks like good. Now we are not to find out Q naught. Q0 is the final stable charge on this capacitor. As the capacitance on this, as the voltage starts increasing on this capacitor, finally it reaches the same value as this voltage. At that particular time, the charge on this is given the final maximum charge to be given by CV naught, where V naught is the voltage on this battery. With the Q is known, we can substitute this Q value over here. So E becomes half into Q square is C square V naught square 1 minus e to the power t by RC whole square. Once C goes away, we need to find out half C V naught square 1 minus e to the power t by RC whole square. It is always a good idea when you have a problem to note down all the values given, like here. From these given values, we can find out the capacitance C. The capacitance C is used twice in this calculation of the energy, so it's better to calculate E, and we have used C here as well. Once you have calculated C, you can fit everything in this formula and find out the value of the energy stored in this capacitor.